Now, considering this particular question we have here, so let's move straight to the solution. Now, considering this particular question, this is an exponential indices such that we are actually given 2 raised to the power of 2x minus 1. This particular expression here can be written in a separate form, whereby I can decide to write it as 2 raised to the power of 2x divided by 2 raised to the power of 1, because according to the rule of indices, whenever you have the same base with either different or the same power, just take the base as a single one and then you subtract the index you have, that is the power you have for them. Whenever it is being separated by division sign, you subtract it. So this particular expression here and what I've just written here, they are both the same. So the next thing for us to do here is to continue with the remaining expression. So I have to do the same thing for this. You have 2 raised to the power of x minus 1. This 2 raised to the power of x minus 1 can also be written as 2 raised to the power of x divided by what? 2 raised to the power of 1 equals to minus 9. So I can still decide to express this in such a way that I have 2 raised to the power of 2x here. If I want this expression to look exactly something similar to this, that means I can write this 2 raised to the power of 2x as 2 raised to the power of x inside the bracket, and then these 2 remain outside. So 2 raised to the power of x all squared is still equivalent to 2 raised to the power of 2x. Is that clear? So then the next thing for us to do after that is to divide it by, we need to divide it by 2 raised to the power of 1 minus 11. Then I have 2 raised to the power of x divided by 2 raised to the power of 1, then equals to minus 9. So to reduce this equation we actually have there, we can decide to let substitute 2 raised to the power of x for y. Let 2 raised to the power of x represent y in this case, so that by the time we have this full expression, I'll write it as y squared divided by 2 minus 11 open bracket y divided by 2 equals to minus 9. So I've substituted 2 raised to the power of x for y. So therefore, this thing can actually be written as y squared over 2, then minus 11, and this can also be written as y over 2 and equals to minus 9. So I have to multiply all through by 2. The LCM here in this expression, in this equation here, is what is 2. If I multiply y squared over 2 by 2, 2 we cancel 2, I'll be left with just y squared. Then minus 11. If I multiply this y over 2 times 2, this is 10 here by 2, 2 we cancel 2, I'll be left just 11y equals to, then I have to multiply this also by 2, and that will be what? Minus 18. So in this case, I can just decide to collect like terms. By the time we collect like terms, we end up having this comes to the left hand side, we have plus 18 is equals to 0. Okay, and then when you have something like this, we need to find the product of 18 such that if you add them together, the result will give us the coefficient of this linear term. The product of 18 is 9 times 2. So and I can also have minus 9 times minus 2, minus 9 times minus 2. If I add this together, I will surely have minus 11y. So let me use this expression here. So that will be y squared minus 9y minus 2y, then plus 18 equals to 0. The common factor here is just y squared divided by y as y minus 9. Minus 2 is common in this case, then I'll be left to just y minus 9 also equals to 0. So looking at this, y minus 2 will be equated to 0, y minus 9 will be equated to 0. So y is equals to 2 or 9. So this is not our final answer. You still have to recall, this back. That 2 is power of x is equals to y. Then when y is 2, I should have 2 is power of x is equals to 2. When y is 2, that's 1. This cancels this, then x is equals to 1. Final. Then at the same time, 2 is power of x is equals to 9. That's another thing entirely. So for you to get the result to this, then you have to make use of, you have to take the natural log of both sides. Yes, you have to take natural log of both sides. So in that case, I'll explain it to you. Now recall that we actually have x to be equals to 1 for the first result. Actually, we got this result from this 2 raised power of x is equals to y, such that we got our y to be equals to 2 or 9. So it's the answers we got for y. And the next thing for us to do from here is to substitute for when y is 2. Then this thing can also be written as 2 raised power of 1. Then this cancel this, and I have s is equals to 1. So this is very easy. Now for the second part, that's what I want to explain. If 2 raised power of x is equals to 9, what are you going to do? How will you get the result for x? So just take the natural log of both sides. That is, natural log is ln. And so in this case now, I have ln, take the ln of both sides. I've taken the ln of both sides. If I cancel this, it's still the same thing. I've not done anything wrong to to this expression. If I cancel this ln and ln, I'll still have 2 raised power of x equals to 9. So in this case, the next thing I have to do is to just bring this x backward there according to the rule of logarithm. So since you've not done that, just know that I've actually applied power law of logarithm in this case, such that if x comes down, I have x ln 2 is equals to ln 9. So this natural log of 2 is just a constant. So you can divide both sides by ln 2. By what? Ln 2. So if this cancel this, I have x is equals to ln of 9 over ln of 2. You can actually punch this into your calculator to get your final answer. And if you do that, you get this result 3.1699. You go ahead and press that on your calculator. So um this particular result for that question, x is equals to 1 or 3 points, approximately 3.17. Let's leave it that way. So that's how it's going to be. Thanks for watching.